Here at the University of South Florida, our research group believes that education is the key to sustainability, and education starts in the K-12 classroom. Now, since 2008, we've worked closely with Hillsborough County Schools teachers and administration with the overarching theme that every school can be transformed to promote the development of sustainable, healthy communities through hands-on, inquiry-based science education centered around accessible infrastructure and the development of green spaces on school campuses. Our K-12 partnerships have allowed us to investigate new learning methods and develop a unique green space-based learning framework. The innovative feature of the green space-based learning framework is that it provides K-12 students with direct access to practicing engineers and environmental engineering graduate mentors to develop real-world, current research solutions to grand engineering challenges that affect their local community. Through the initial investigation process, students identify a challenge, and through the support of the partnership, a curricular unit consisting of innovative lesson plans and interactive activities is developed. The Green Space-Based Learning Framework supports multiple educational and observational research outcomes, which must include, but are not limited to, student-driven curriculum and the design and construction of an urban infrastructure improvement within their school campus. The key to the Green Space-Based Learning Framework is its continuous evolutionary component and iterative developmental process. For example, Hillsborough County School teachers are given the opportunity to participate in a 6-week Research Experience for Teachers summer program at the University of South Florida. These teachers set up and collect laboratory and field data on current graduate students' research projects and transform what they have learned to create grade-specific lessons and activities to support the K-12 green space-based learning environment.
Teachers and undergrads and students that will be going into Hillsborough County perhaps, we could actually look at the Hillsborough County standards. And what that really means is that, for instance, the unit that I did was on human impacts on the environment. That's one of the biggest biology objectives there is. The teachers in the county can pull that up. They can see our interactive technologies in the lesson plans that we've done. They can see the actual labs, the chemistry and the biology lab that I put together. And it's things that we've done in the county that we're successful at doing as teachers. And now we're connecting them to our research here and publishing them. And so now everybody can use them.
The things that students are always curious about are what teachers actually do. They just think that, we come in, we teach them what we have to teach them, and that's pretty much it. So this program is going to show them that we actually go out into the workforce, out of work, and learn more information on what we already know. So we're learning while they're learning.
This is doing is taking at that higher order thinking, the civil engineering level, the environmental engineering level, and bringing it to a basic level, which will be a high school level. And so now they can make the connections for science, for technology, for different innovations, and the types of technology that they're doing with the green space-based learning can be implemented in a school campus, and that will be kind of that authentic task that can inspire kids maybe later on to become environmental engineers.
From 2011 to 2013, Young Middle Magnet, a Hillsborough County school located in East Tampa, has successfully implemented the Green Space-Based Learning Framework. Here, students identified 2 grand engineering challenges. One being to improve and restore urban infrastructure, and the second, proper management of the nitrogen cycle. One of the curricular units implemented at Young Middle Magnet is titled Urban Stormwater Management. This unit addresses techniques for managing stormwater at the source to improve and restore the hydrology and water quality of a developed site to that of pre-development conditions. Throughout instruction, students are introduced to green infrastructure and low-impact development technologies and take on the role of stormwater scientist or engineer. The students investigate the difference in infiltration rates between several types of native media and pervious pavement mix combinations, as well as participate in a native plant species selection based on evapotranspiration rates, aesthetics, and accessibility to wetting and drying conditions to create a personal rain garden. Evolving from the Urban Stormwater Management Curricular Unit, students identified an area within their school campus that would benefit from green infrastructure improvements. The students participated throughout every phase of the design and construction of a municipality-scale bioretention system implemented to alleviate campus flooding and manage non-point source pollution. Students performed surveying activities, project management roles, weekly site assessment, sizing of the bioretention system based on overall catchment area, excavation, media layer selection, media layer installation, native plant selection, plant species installation, underdrain sample port installation, final elevation grading, and performed weekly tasks for the bioretention system post-construction. The data collected from this experimental bioretention system is currently being used to support research experiments at the University of South Florida Botanical Gardens to help aid in Florida native plant species selection for green infrastructure improvement projects. If you would like to receive additional information on green space-based learning or links to the curricular unit, please contact Ryan Locicero with the University of South Florida Civil and Environmental Engineering Department.
And so teaching the physical science class, within my curriculum, I have a 2-week window where I can implement the green space-based learning. And so I take that and I can survey my school campus and look for areas of need where that technology can be done. Teach the kids how to do it, teach the kids how to get the rain gardens in place, and then actually doing those with these kids, with the students, and those low technology development infrastructures will be in place for other kids to see, for not only the beautification of the campus itself, but also to be a technology that is improving the ecosystem or the system on the school campus.